So today our topic is to do second order heading, second order derivative. As we know, as we have in like physics, we have already done this kind of thing. It's like we learned that v is equal to dx by dt. We used to do all this, okay? And for acceleration, we used to again differentiate with respect to t to this velocity. Suppose I would write initially velocity. So it will be like, for a science student only, you can understand, we used to do all this. And even for v also, if you substitute v, it will be dx by dt again. So we used to write acceleration is d square x by dt square. This we used to do in 11th standard physics. So similarly, second order derivative, matlab again we are doing one more time derivation to be done for dy by dx or whatever is asked for. So let's take one function y is equal to fx. Therefore, your dy by dx, that means if we are doing differentiation on both sides, we mention with one dash f dash x. One dash matlab one time derivative. Suppose I need to do one more time second order derivative. Matlab we are doing the derivation of above. Okay. Matlab d by dx if we are doing to this one above. Again, okay, so in that case it is mentioned as d2y by dx2. Sometimes we can use d square y by dx square or d2y by dx2. It's same thing. Here it was one time dash when we do the derivation one time. Here we are doing one time, the derivation is done. Again one more time we are doing, so f double dash x. So that is called as second order derivative. Here you can see this d2y by dx2 is called second order derivative of y with respect to x. Here we can see, because d2y by dx2, it says that we are doing derivation twice, two times. Matlab second order derivative of y with respect to x. How we can denote it? It is also denoted by d2y or y double dash or y2. Okay, capital D also represents d by dx. If it is d2y, that means we are doing second order derivative of y. Y double dash matlab second order derivative of y with respect to x, obviously. Y2 matlab generally y2, again these are general things. Matlab we are doing the derivative with respect to x only, general thing. So let us start exercise 5.7. This exercise has a lot of questions, but the funda is same. We are going to do two times the derivation. Okay, it's just derivation should be done twice. First, find the second order derivative. It is clearly mentioned that we have to do second order derivative of function. From 1 to 10, we are going to do this thing. So obviously, whenever some function is given, first thing we do that is naming ceremony. This is my naming ceremony. I had given name that let y is equal to x square plus 3x plus 2. Now to find second order derivative, first of all, at least first time we have to do derivation on both sides with respect to x. So that means left hand side also d by dx and right hand side also we are doing d by dx. So we are differentiating both sides with respect to x. It's like dy by dx left side as it is. Right hand side, as we know, that rule says that if you have u plus v, what do? Du by dx plus dv by dx. That means here you are differentiating x square first of all. So x square का क्या होता है? So x very simple, 2x. Square का 2x. It's simple. Plus है तो plus as it is 3x. 3 to outside. That means dx by dx, because See, when we do d by dx of 3x, it means that 3 is constant outside. That means dx by dx, but dx by dx is 1. That means the answer is 3. 3 ones are 3. That is 1, 3. But what about 2? 2 is constant. This is constant. 0. That means no need to mention only. 2x plus 3 plus 0, that means 2x plus 3. This is first order derivative, but since we have to find out the second order derivative, again we are doing derivation on both sides, differentiating both sides with respect to derivation, I said, sorry. Yeah. So differentiating both sides with respect to x. That means we states with d2y by dx2 is equal to, again the same rule, addition rule, 2x, 2x ka 2, because x ka 1 hota hai always. Differentiation of x is 1 with respect to x. Plus 3 ka 0. Okay, so only 3, if I would write chalo 0, I will mention, so that I had already written the numbers, this sign, so I had put 0. Otherwise, answer is simple. This is your answer. Yeah, the first time it was done, that is why I had slowly gone, but now we are going to do a little faster. Let's increase the speed. Let, first of all, naming ceremony, x to the power 20 ka. Let y is equal to x to the power 20. Then differentiating both sides with respect to x, d by dx of x to the power 20. As we know, how do we do? nx, matlab whatever the power, x to the power n minus 1, 20 minus 1, 19. This is your first order derivative, but since we have to do the derivation, again second order we are finding. That means I have to perform one more time differentiation, both sides, differentiating both sides with respect to x. Here we can see that 20 can be taken out. So 20 as it is into x to the power 19. Again, same funda. N into x to the power n minus 1. 19 minus 1, 18. 20 into 19, we have to do the simplification as well. 19 2s are 38, 380, x to the power 18. This is your answer. So these questions are actually very simple. It's just the same thing we are doing 2 times in one question. So that is called second order derivative. Sometimes we are going to use log also. Sometimes we are going to do the different methods also, like product rule and quotient rule. Many rules will be used. As of now, it was easy. Now it is started. You can see that first of all, the naming ceremony. Let y is equal to x cos x. So dy by dx, matlab differentiating both sides with respect to x, will give me d by dx of x cos x. I can see that these two different quantities are in product. So I can apply the product rule. Product rule says that first quantity as it is, differentiation of second quantity, which is cos x, plus second quantity as it is, differentiation of first quantity, that is x. So x as it is, differentiation of cos x is minus sin x, plus cos x as it is, and differentiation of x with respect to x, which is 1. So that means dy by dx is equal to, I can see that this will be like minus x sin x, right? And that one is the cos x. So I can take even cos x first, as it is positive. It's just, it is positive, I'm writing first. Not necessarily we should write like this, but it is positive. So I just simplified it. I need to find out the second order derivative. So I need to differentiate both sides on with respect to x. 3 by dx of cos x minus x sin x. That means it will become d2y by dx2. Right hand side, I can see that I am applying addition rule only. That means for this d by dx, it is cos x minus d by dx x sin x. You would be wondering that now again we are writing the rule also. Here I applied the rule because I had written separately d by dx. Why so? Here I can see it is a product rule will be applied. That is why I just elaborated a little bit. So here differentiation of cos x is minus sin x minus, then I can see that I'm going to apply the product rule. That means I have to write in a bracket. Otherwise, my answer would be wrong. This not need to forget this part. So first quantity as it is, differentiation of second quantity sin x plus sin x as it is, differentiation of first quantity, which is x. So that means d2y by dx2, d2y by dx2 is equal to minus sin x minus, I can see it is d by dx of sin x is cos x. So x cos x was there already. So I just put x as it is, and then cos x, sin x or cos x plus sin x, and dx by dx is 1. So it is sin x. That's it. I'll open the bracket. So minus sin x minus x cos x minus plus minus sin x. As I can see, bracket is going to open and this sign will turn to minus sign. And that is how it is minus 2 sin x minus x cos x. Your NCERT says that we are going to take minus common and then 2 sin x plus x. Paper will be an MCQ, so you know that what will answer will be there, and accordingly you will find your answer. So that's it. Next, fourth one, log x. Again, naming ceremony first of all. Let y is equal to log x. So directly we can do, because I know what is the differentiation of log x. This direct formula. Differentiating both sides with respect to x, d by dx will be applied to both sides. So dy by dx is equal to log x का 1 by x. It was simple. Simple is that. Okay. And x only, it is x only. It's not like the 2x is there. So again, chain rule will be applied and all. It is very simple, log x. So again, we'll do differentiating both sides with respect to x. Now I had told you even on very first or second day of this chapter कि भाई 1 by x भी याद रखो, it is going to come again and again. 1 by x का minus 1 by x. The algebraic expression only we have used, and we found that it is. Keep your list of formula along with you only. It will be very easy if you keep it with. Chale. Fifth one. First ceremony is naming ceremony. X cube log x. Differentiating both sides with respect to x, as we need to find our second order derivative, d by dx on both sides. So d by dx of x cube into log x. I can simply see that it is the two different quantities in multiplication. Simply I'll do that thing only. First quantity as it is, cube as it is, differentiation of log x plus log x as it is, differentiation of x cube as it is, differentiation of log x, simple 1 by x plus differentiation of log x is 1 by x, done. Then log x as it is, log x as it is, but differentiation of x cube is 3x. As I can see, 1x is going to get cancelled, and here dy by dx will be x square. It is 3, this is power 3, and this will be power 1. They are in quotient, so 3 minus 1 is x square plus 3x square log x, because x is not multiplied with 3x square. Full log x is multiplied with 3x square. So that is why 3x square I had written first. Now again, differentiating both sides with respect to x. And that will give me, if it is like this, now you people are not going to add like x square hai and 3x square hai, 4x square kar. No. This 3x square is multiplied log x, but this x square is not multiplied with log x. So we cannot add them. Obviously, we can take common. It's not doing. It's already very silly and simple. So d2y by dx2 is equal to. Obviously, we are separating first of all, because I can see here I have to apply product rule. So I'm just giving this, showing the separation also, dy dx. So d2y by dx2 is equal to, first thing, d by dx of 2x. 2x so very simple. Sorry, x square. D by dx of x square, which is 2x. I said the answer actually. Then you can see that 3 is multiplied with both the things. Obviously, that means 3 can be taken out, and then I'll make a bracket and to show that this is your first quantity, this is your second quantity. And they are in product. First quantity as it is, differentiation of second. Second quantity as it is, differentiation of 3 is out, by the way. So first quantity as it is, differentiation of log x plus log x as it is, and differentiation of x. Now I know what is the differentiation of log x and differentiation of x square. Let's do that. 2x plus 3 out, so x square. This is 1 by x plus log x as it is, and x square. Differentiation of x square is 2x. Differentiation of x square is 2x. 1x got cancelled, and then I'll open the bracket as well. So 3 will be multiplied. So it is 3x plus 3 will multiply with the other one also. It is 3 to the 6x log x. You can see that 2x plus 3x is 5x plus 6x log x. And your NCERT is giving the answer x common 5 plus 6. So you cannot add 5x and 6x, 11x. Huh? You can take only common. X is taken common, and 5 only as it is there plus 6 log x. Let's do the next question. Next one. Naming ceremony. Let y is equal to e to the power x sine 5x. Again, we can see two separate functions are in multiplication. Product rule will be applied if I'll do differentiation on both sides. Let's do that. First quantity, e by e to the power x as it is, d by dx of sine x, sine 5x, plus sine 5x as it is, into d by dx of e to the power x. I can see d e to the power x as it is, into sine 5x cos 5x. It's just, I cannot change the angle. The angle is as it is, sine x cos x, sine 5x cos 5x. But yeah, but as we have to apply the chain rule, this angle will be again under the derivation. Okay, so it is sine plus sine 5x as it is, e to the power x ka e to the power x. So that is how e to the power x into cos 5x into 5x ka 5, because dx by dx is 1. So 5 as it is, plus sine 5x into e to the power x. As it will be very easy if we take common. So e to the power x is common from both the terms, and we have 5 cos 5x, because this 5 is multiplied with full cos 5x. It's not multiplied only with 5x. So 5 is a 25x. It's not like that. Huh? 5 is multiplied with full. So I can take out before cos 5x. 5 cos 5x plus sine 5x. But since we have to find out second order derivative, let us do differentiating both sides with respect to x. D by dx will be on both sides. As I can see that this is again product wala part. This is first quantity, this one is second quantity. Left side, so we know it is d2y by dx2. right side we are going to use the product rule. You have to be careful now onwards. No? So my d2y by dx2 is equal to first quantity as it is, d by dx of bracket as it is, bracket ka differentiation, sin plus I cos 5x plus sin 5x as it is, and differentiation of e to the power x. So e to the power x as it is. Let's do the differentiation of this full bracket. I can see that again we have to use the addition rule for this differentiation one by one. We are not going to write the full state thing, but I can write down the answer. 5 as it is. Then I have cos 5x. Cos 5x minus sin 5x. But again chain rule must be applied. We have to do the differentiation of angle again. Okay. This cos 5x got over. The second part of this bracket. Okay. That means it is in plus sin 5x cos 5x. But again the angle is not only x, it is 5x. Again need to be done. Plus. Plus के बाद this part is there. 5 cos 5x plus sin 5x. E to the power x, anyone remember? E to the power x. And it is x only. If it is 5x, then again chain rule must be applied. But it is 5 only, this one. It's fine. So let's, I can see that here, the first part may, it is too much simplification is required. So let's do that. It is minus, first of all, these two are multiplied. So minus 5 sin 5x into d by dx of 5x is 5 plus cos 5x, this part, d by dx of 5x is plus 5 cos 5x as it is plus sin 5x into e to the power x. We know that e to the power x can be taken common from both the terms. So these brackets are going to be in addition. See that there is a plus sign between them. So minus 5 is at 25 sin x sin 5x plus 5 cos 5x plus 5 cos 5x plus sin 5x into e to the power x तो common था तो minus 25 sin 5x and plus 1 sin 5x subtraction minus 24 sin 5x. And then in next is like plus 5 cos x plus 5 cos x, so plus 5 plus 10 cos 5x. I can see that 2 can be taken common from both. Yeah, say 24 में से 2 and 10 में से 2. 2 into e to the power x. I can see that something is positive. So let me write positive number. I'm writing 5 cos 5x first minus 12 sin 5x later, and that is our d2y by dx 2. And that's actually given in your CRT. Seventh question. Don't worry if you like do not understand. Again, you can ask me. Even you can watch the video. I'm going to upload today itself. Let's do naming ceremony for this. Seventh one. Let y is equal to e to the power 6x into cos 3x. Naming ceremony kar liya. Now, as we know, 1 to 10, we have to find out the second order derivative. D by dx on both sides. That means I can see it is a product rule. Simply, I could see easily. First quantity as it is differentiation cos 3x plus cos 3x as it is differentiation of e to the power. Getting? So e to the power 6x. Such differentiation of cos is minus sign, but we have to apply the chain rule of plus cos 3x as it is, e to the power 6x by e to the power 6x, but it is 6x. It's not only x. Chain rule will be there. Chain rule with the power also. Yes. फॉर्मूला से जरा सा भी इधर उधर हुआ तो चेन रूल अप्लाई. Sin 3 e to the power 6x and sin 3x as it is. 3x का derivation differentiation is 3 and plus cos 3x e to the power 6x and इसका. So we can take something common also from these two. I can see e to the power x also, and I can take 3 also. 3 into e to the power 6x is common. And I'm writing positive things first. So it is like 6 tha na, 2 bahar nikala. 1, 2 is 3 I took out. 3 2s are 6. That means out of this 6, I have taken 3 out. But 2 is still there. That means 2 cos 3x minus sin 3x. You should not forget minus sign. This is like first order derivative is done. Second order ke liye again d by dx on both sides. It's like form. If you know all the like formulas, then it is fun. D by dx of now what we can see here, I can see that 3 can be taken even out. I can take out 3 and this will work as your first quantity. This can work as your second quantity. So let's do so. 3 is out from all these functions. So it is d2y by dx2. 3 is out already. Now inside the bracket, first quantity is e to the power 6x out as it is, into differentiation of second quantity, which is 2 cos dx minus sin 3x. Right? And this, we did that part. Okay. So differentiation I did not mention. Differentiation. Plus that full bracket as it is, second quantity as it is, differentiation of first quantity. Simplification starts. We'll apply the differentiation addition rule. E to the power 6x to as it is. Now I can say I'm using curly bracket as well. 2 as it is with cos. So cos ke saath it is like minus sign, right? Minus sin 3x, whatever the angle is. 2 cos 3x ka differentiation will be minus sin 3x. Angle will be the same, but we have to do the differentiation of angle also. Minus sin x cos 3x, but again we have to apply for the angle. Plus 2 cos 3x minus sin 2x sin 3x as it is. Differentiation of e to the power 6x is e to the power 6x, but chain rule says that you have to apply for this power also. 3 is out. Let's do simplification. E to the power 6x 2 minus 2 sin 3x into 3x ka 3. X ka 3 minus cos 3x as it is, and d by dx of 3x is 3. This is like first bracket plus second bracket says that is the as it is. E to the power 6x also as it is into 6x ka. I can see in the both terms we have e to the power 6x. Let us take e to the power 6x out. E into e to the power 6x. Now remaining part 3 to the 6 minus 6 sin 3x minus 3 cos 3x plus, I'm opening this bracket. I'm opening this bracket now. That means it is plus, all these are going to be added as I have taken 6x outside, e to the power 6x outside. So 2 cos 3x minus sine 3x. You can see that whenever angles are same, the numbers can be multiplied, right? Like sine 3x and sine 3x, but 8 minus 6 and 8 minus 1. We can add actually. ये हाँ ये 6 रह गया, oh 6 रह गया, 6 2s are 12, right? यहाँ पे 12 आएगा, this one. This 6 is multiplied. This 6 was not out, 6 2s are 12, and ये 6 हो जाएगा. Minus 6 sin 3x and minus 6 sin 3x minus 12 हो जाएगा. So it's d2y by dx2 is equal to 3 into e to the power 6. Then minus 6 sin 3x and minus 6 sin 3x. It's minus 12 sin 3x. Again, one more thing we could see that minus 3 sin cos 3x and plus 12 sin cos 3x. We have to see that 3x. Huh? Angle should be same, otherwise we cannot add them. Minus 3 and plus 12 plus 9 cos 3x. I can take something common. 9 and 12. 3 is common. So d2y by dx2, 3 is common. That means 3 3s are 9 e to the power 6x. And I am writing positive number first. So it remains, see, 9 means already 3 is out. Okay. What remains? 3 remains. So that is why 3 cos 3. Here, minus sign first of all. Minus 12 means already 3 is out. So 4 remain. 4 sine. Next question, 8th question. It is very simple, easy question. Hai. 10 inverse x. It's just one identity you have to remember. First thing we have to do, naming ceremony. After the naming, you know, it's not having like exponent power and also you can directly apply the differentiation both sides with respect to x. This is nothing but a formula, 10 inverse x ka 1 by 1 plus x. This is direct formula. Since it is x only, x square, yeah, anything, other things are not there. Direct x, so it's like x. Again, we have to differentiate both sides because as we have to find out second order derivative. D by dx of 1 by 1 plus x square. It is d2y by dx2 equal to, here you can see, it's like, कहाँ पे किया है ऐसा कुछ? So I know d by dx of 1 by x we do. It's minus 1 by x square. So just imagine that this 1 plus x square is only x. Chalo t hai. So 1 by t matlab minus 1 by t square. That means 1 by minus 1 by 1 plus x square ka whole square. But it is not only x. It is 1 plus x square. That means chain rule will be applied to this. One can understand with the t method also. Okay, chalo, let t is equal to 1 plus x square. So dt by dx is equal to क्या होगा 2x. Okay, that means when you have this dy by dx क्या हो गया था आपका 1 by t is 1 by 1 plus x square. 1 plus x square we assumed as a t. So that means if you are doing differentiation both sides, so here तो if you apply, it will be minus 1 by t square. But you have to apply the chain rule. So that means 1 plus x square ka to square, but dt by dx is 2x. So that will be your answer. And here also we are doing the same thing. With this method also, with t method also you can do, but I told you t method we are doing at the initial stage only. Later on we are going to do directly. So that's what we are doing. Here, so we understood this one. But what about the differentiation of this? Addition rule. 1 ka differentiation is 0 and x square ka differentiation is 2x. So that is how your answer is d square y by dx square is equal to minus 2x on 1 plus x square. And you can see this is also giving you the same thing. Okay, so t method is also giving you the same thing. Whatever, if you are comfortable with that one, we can do that one also. It's not like that. Ninth question. Naming ceremony. Let y is equal to log of log x. Differentiating both sides with respect to x. Again, you are a little confused with how to do it. One can assume this log x as a t. So it will become log t. And log t ka differentiation is 1 by t. But here I am doing directly. You can see it. I know the formula, right? If my funda is clear, I'll be doing directly. By log x, if x is there, x will go in denominator. Here, in place of x, I have log x. So log x will go in denominator after the differentiation. Simple. But it's not x, it's log x. That means again, we have to apply the chain rule for this. जैसे एंगल हुआ करता है sin x, तो x का करना पड़ता है. If x is not there, x square is there, or 1 plus x is there. So here also, it's not x, it's log x. So again, we have to do the log x part. And 1 by log x. And ye to log x again, it is 1 by x. So that is how dy by dx is 1 by x log x. 1 by x log x. Done. But as we are finding the second order derivative, differentiating both sides with respect to x again. ये तो अभी हमने किया वैसा ही है. It's like d by dx of 1 by x is algebraic formula wala minus 1 by x square. But it's not x, it's a x log x. So again, chain rule will be applied for this denominator. If x is there, then no chain rule. But here for this dotted part, I have to apply the chain rule for this also. So that means d2y by dx2. What about the d by dx of 1 by x log x? So it's like minus 1 by x log x ka square. This is from the formula. I know this, right? But after this, as chain rule need to be applied for this. It was not x, it was x log x. So I have to apply this. But ye to apna fir se product rule first and second quantity. So I have to apply that only. first quantity as it is, differentiation of log x, plus second quantity as it is, differentiation of first तो ऐसे ही छोड़ा हमने, not doing anything with this term, x into log x का 1 by x plus log x as it is, dx by dx is 1 and x got cancelled, so even this part is also 1, right? So it is minus x log x square 1 plus log x. What is it? See? Simple. NCERT will give in proper way of write up. You can see that we cannot cancel log x cut करके 1 plus 1 by x square. No. Not cancel. Cancel. If it is getting cancelled, then full bracket will be getting cancelled, not like single thing inside the bracket. The next thing, to 10 जो करने थे उसमें d2y by dx2. Naming ceremony, let y is equal to sine of log x. This is not so difficult, right? It's simple now. It's just in place of x we have log x. Matlab chain rule will be there. Okay. First of all, let us differentiating both sides with respect to x. Sine of log x. What about sine ka differentiation is? Cos. But whatever the angle is, log x is angle for log x. But angle is not x, it is log x. So let me apply the chain rule for this. We have to apply chain rule. Because it is not x. If it could be x, no chain rule. Cos of log x into log x for 1 by x. The first part is done. You can see that dy by dx is cos of log x upon x. Second order, we'll try second order. Differentiating both sides with respect to x. Cos of log x. We can see easily that we have to apply the quotient. Quotient rule must be applied over. How we do denominator as it is, numerator का differentiation minus numerator as it is, denominator का differentiation. तो first हमेशा numerator होता है, denominator के time के पहले minus sign होगा. So let me do one new page. It is d2y by dx2 is equal to denominator as it is, numerator का differentiation plus minus quotient rule है, minus आएगा minus numerator as it is, denominator just made a mistake. Numerator as it is, denominator का upon denominator का. As I can see, it is dx by dx. So this part though is going to become 1 only. Dx by dx is going to become 1. तो यहाँ पे थोड़ा काम करना पड़ेगा. See, x d by dx of cos of log x. Cos of log x मतलब minus sine of log x, but need to apply the chain rule for angle. Minus cos of log x, dx by dx is 1 upon denominator square. X is not only x, but it is like minus sine of log x into log x ka to 1 by x. And all three are in multiplication. By the way, the x is going to get cancelled later on. Minus cos of log x as it is into 1. So, okay. X got cancelled and I got minus sine of log x minus cos of log x upon x square. As your NCERT says that minus can be taken as common, and you will be having sine log x, minus is out, plus log x upon square. Here we completed the first part of the exercise, which was finding second order derivative, which was very simple actually. If you are, one knows that how to do the first order derivative, can be easily done as the second order. कुछ नहीं है, एक और बार करो second order derivative. Let's do the 11th one. Now onwards we have little proof and all. These are like proof, matlab we know the answer. It's just setup is to be done. And you know that this will be MCQ paper. So in your paper, you would be thinking, as a question क्यों कर रहा है, prove that तो आएगा नहीं. But हाँ, they will give you y is equal to so and so, and then you will be having in MCQ, you'll be having one of the option like this. So which one is true? So you're going to check. Maybe the 2y by dx square is plus 2y is given. Yeah, somewhere here it is 1 given. So you need to check which one it will be true. So that way the question can be on. So let us start. Here I can see in proof, no, I want second order derivative. Okay. So I can start with the LHS and RHS, or maybe direct also I might get. So let me start with y, then first order derivative, then second order derivative, and then we will find y is equal to 5 cos x minus 3 sin x, first order derivative, dy by dx, both sides dx, dy dx, 5 cos x minus 3 sin x, dy by dx is like addition, addition rule, to 5 as it is, but it is minus 5 because it is sin x will be minus 5 sin x minus 3 sin x ka cos x. I'm just applying directly. It's just cos x ka minus sin x. Well, is x only, so no need to do the chain rule. It's direct. Let's do second order derivative. That means it is d2y by dx2 is equal to d by dx of minus 5 sin x. Sin x ka derivative is cos x. So minus 5 cos x, and d by dx of cos x is minus sin x. So ultimately it will turn to plus 3 sin x. But if we see this properly, no, it is like something related to y. You see, whatever we got, it looks like y only, no? Suppose you take here, it's just here it is minus and we have plus here. And here 5 is plus and here we have minus. So what do? I take minus common. I'll take minus common and sign is changed. Now this is nothing but your given y. And that only needed to prove, no? Now I'll take y that side. That is why I made the setup, and I know that plus y it will become it goes that side, and nothing is there right hand side is that means equal to 0. Hence proved. So this kind of proofs are there. No need to worry. It's just you should know all the identity. All about identity. Once you know this, then only we can go further for 6th chapter, otherwise of no use. 12th, here also, we have to find out d2y by dx2 in terms of y alone. Y alone. Matlab the answer should be also in terms of y. So here some setup will be required. We'll do. So we have y. Y is given. Now as I want d2y by dx2, let's do first order derivative. D by dx on both sides. Cos inverse x formula is known, well known formula, minus 1 by under root of 1 minus. Again, I have to perform second order derivative, but this will be if it is in power terms, it will be very simple to get the answer. So that is why I'm writing in different way. You can see that I'm going to write in minus as it is. I'm writing in different power. It is like if it is in denominator, root x we can write as x to the power half. And if it is 1 by root x, matlab it is like x to the power minus half. It is in denominator. So it's nothing but minus half. 1 minus x square to the power minus half. Okay. Because we don't have the, in list of formula, we don't have this by differentiation of 1 by root x. We didn't do. Okay. Only root x we have done. Only root x we know. Okay, by it is 1 by 2 root x. Okay. This one we did. So now again, we are going to differentiating both sides with respect to x. Minus outside I took, you can see that I took minus outside. Minus is irrespective of this d by dx. So d2y by dx2 is equal to minus outside. And I need to do here, first thing I can see that it is having power. So I need to solve in power way, like we have algebraic that formula also, identity also, that power n into x to the power n minus 1. That means it is minus 3 by 2. Achha, I will write. Otherwise, after some time you might forget. Okay, here we applied this one. Which one we applied? D by dx of x to the power n is equal to n into x to the power n minus 1. This we applied. It's just x ki jagah pe 1 minus x. That means again I have to apply the chain rule. Chain rule need to apply together only. ऐसा नहीं कि इसको पहले solve करेंगे and then you will apply the chain rule. No. You have to apply in the same line itself. Okay, same way only. Same line when you apply there, here also need to be applied. Minus, all three are in multiplication. Everything is multiplication. Minus will become plus half y minus x square to the power minus half minus 1 minus 3 by 2. And 0 ka like differentiate, 1 ka differentiation is 0. And minus, then minus sign. Because minus sign was there, so minus sign. And x square 2x. So again minus sign, but 2 got cancelled. So that means my d2y by dx2, my d2y by dx2 is equal to minus x upon 1 minus x square to the power 3 by 2. Is it okay if I write this one? Because it was minus 3 by 2. I wrote in denominator. Since the question says that I have to find d2y by dx2 in terms of y alone. I should not have this x at all in this answer. I need to remove all this x. From where should I remove? So I have y is equal to cos inverse x. Please, you can continue at the same side here only. Otherwise, if you have space at side, you have to show this. You have to show this. You cannot write directly. That means if you remember inverse trigonometry, we know we can write x is equal to cos. That's it. Done, no? I'll apply everywhere. Minus x matlab cos y, because x is cos y. So it's like 1 minus x square. X square is cos square y to the power 3 by 2. 1 minus cos square y is like sin square y. Old identity, 10 standard identity to the power 3 by 2. Power's power. 2 into 3 by 2. 2 will get cancelled. It will be minus cos y upon sin cube y. And that is how I can see it can be converted into cos by sin, cot y, and baki ka ek aur sin square y is there in denominator still, because cos y upon sin y into Still one more sine square y is there in denominator, that is cosec square y. So we had given the answer in terms of only and only y. This type of question is very, very important. 12th number question was important. Let's do the next one. 13th. We have y is equal to so and so. Show that this one. Show that you can see that here we can see y1 is also there, y2 is also there. Y1 matlab you just understand as dy by dx, and y2 matlab d2y by dx2. That's it. Nothing else. Then we can start with LHS and we can reach to RHS. But for LHS, we have to have y2, we have to have y1. So in this question, dy by dx, we can write as a y1 by the way, or later on we can change. Anything, whatever we like to do. Y is given. Let us start D. It is y2 is required. That means we are going to find out second order derivative. Then we will see what can we d by dx on both sides. These two are in sum. Addition rule will be applied. And this log x is not multiplied. It is angle. Huh? It is angle. These two are angles. 3 is out. Then differentiation of cos is minus sine angle as it is into differentiation of angle, because it was some different weird angle. So again uska bhi karo. Agar weird kuch bhi hai, angle wangle chain rule mein la do. Plus 4 as it is. Differentiation of sine, it is cos log x. But again angle is some weird chain rule. We have to apply this. So let's do opening the brackets. Minus 3 sine log x into 1 by x plus 4 cos log x into 1 by x. If we see in the question, we can see that x y1 middle term, you can see x y1 matlab dy by dx. So my x is there in denominator. You can see x is there in denominator. So I can take x that side. It will go in numerator. So right hand side 1 by x is removed from both the terms. Ultimately, this 1 by x took common, and that 1 by x common goes that side, which goes in numerator. So that's what we did. Plus 4 cos log x. But still, we need to find out x square y2, second order. So let's do differentiation both sides with respect to x. So again, right hand side also. Now left hand side also we can see easily some two are in product. The product rule must be applied at left hand side also now. So x as it is, differentiation of dy by dx. So it is d2y by dx square, y by dx2, plus dy by dx as it is, and differentiation of x, dx by dx. I had to apply product rule left hand side. Is equal to, now again for this minus 3 common, matlab constant outside. Now sine ka cos of log x, chain rule will be applied for this weird kind of angle. Plus again we'll do the differentiation of second part also. 4 as it is, cos का minus sign. So can I write directly? Here I am taking -4. Directly लिख लिया. And for weird angle, again differentiation of this angle is. By the way, -3 was multiplied with only this bracket. Sign के साथ, मतलब इसके साथ. And this 4. You can see this 4 is multiplied with this part. So that is why 4 should be multiplied with this part. So need to see this properly. Okay, what is multiplied with what? Accordingly, we have to. Left side by dx by dx is 1 by the way. So let's write the simplification. Now it's done. So it's x d2y by dx2 plus dy by dx into dx by dx is 1 into dx by dx 1. No need to write that part. Minus 3 log 3 cos log x into differentiation of log x is 1 by x minus 4 sin log x. Again, differentiation of log x is 1 by x. One can see easily that both terms are having 1 by x common, and x will multiply at right left hand side. So it will turn x d square y by dx plus dy by dx minus 3 cos log x minus 4 sin log x. Let us multiply x inside. So x square d2y by dx2 plus x dy by dx is equal to, you can see that right hand side you can compare easily with your given y. If you see, it's just both became minus. Let me take minus common then, so that I can substitute that as y. I'm just setting up, going towards the end of topic. So it is x square d2y by dx2 plus x dy by dx as it is, left hand side as it is. This is nothing but your y. Okay, hence proof, right? X square, it is y2, second order derivative, plus x y1, first order derivative. This minus y will come this side, plus y is equal to 0. Hence proved. Next, we have 4 more questions to complete. So here it is given, somewhat like that kind of things are only there. I can see that d2y and dx2 is there in this proof. I need to prove that. Let me start with y, and I'm going to do second order derivative, obviously. So it is dy by dx, d by dx of a into e to the power mx plus b into e to the power nx. Just imagine that this a and b, these are going to be taken as constants. We are not going to do anything with it. It's like number we used to take outside, 3 and 5 are outside from the differentiation. So that way only we are going to take. So a here differentiation for like addition rule, a is out. E to the power x है तो differentiation is e to the power x only. So mx है तो mx. But this power is weird. That means ये weird power का भी करो chain rule, multiplication. After that we finished only this part. Then plus sign will come, and we have to do the other part also. B as it is. e to the power nx का differentiation is e to the power nx, but as the power is weird, we have to apply the chain rule to the weird power. This is your second term. Okay, let's do the simplification. Matlab again, d by dx of mx. M is again constant, so m will go outside. d by dx of mx, m will go outside. So dx by dx is 1. The answer is m. It's like number. 5x ka 5, 3x ka 3, minus 3x ka minus 3. So it's like mx ka m. Plus b into e to the power nx, nx ka n. That means we have answer in this case m into a e to the power mx plus n into b e to the power nx. I just arranged them. Let me do differentiation one more time to this. I cannot take anything common. By the way, everything is different from both the things. Otherwise, I would have taken common. My term would become more simpler. But no, thing is common in them. Let's do second order derivative in this case. So it's d2y by dx2. d2y by dx2 is equal to, right hand side you can see the same way we are going to do. We are going to apply the sum rule, addition rule. M into a constants. That means m into a as it is. E to the power mx, e to the power mx. But since we have to apply weird power for chain rule, plus n into b to the power e to the power nx same way, but weird power के लिए weird angle के लिए chain rule, weird x के लिए chain rule, weird power के लिए chain rule. So these are terms so that you can relate and remember. So d2y by dx2 is equal to m into a e to the power mx. Here we can see that mx ka to m. We understood 5x ka 5, minus 3x ka minus 3, 5x ka m, and b e to the power nx, nx ka n. That means my d2y by dx2 is equal to m square a into a to the power mx, m into m. Here n into n, so plus n square b into n to the power mx. So in that case, I have dy by dx also. I have d2y by dx also. I can substitute in LHS. Okay, we have to show that something d2y by dx2. So let me put in LHS. Let me try. Okay, am I getting the answer 0 at right hand side? So that's the thing we are going to do. Let's start. So now we have d2y by dx2 minus m plus n into dy by dx plus mn by, which is equal to d2y by dx2 तो already हमने अभी किया, इसको substitute कर लो, minus m plus n dy by dx भी अभी हमने find out किया है, m into a to the power e to the power mx plus n into b to the power b into e to the power nx plus mn y plus mn, y को मत छोड़ो, y को भी substitute, e to the power mx plus b into e to the power. If we open this, how can we open? It's just like we are going to open the bracket. Simplification, sub simplification, सारी चीजें open होती. M square a e into e to the power mx. First two terms are as it is. Minus m is going to multiply with the full thing. Plus minus mn, minus plus minus mn, b into e to the power nx, then minus mn a into e to the power mx, plus minus n square b into e to plus mn a into e to the power mx plus mn b into e to the power mx. Done. Let's check whether we are getting 0 or not. M square a into, oh हाँ, m square a into e to the power minus m plus n square वाला भी है अपने पास, Then minus mn b wala, minus mn b wala, minus mn a wala, minus mn everything we got, and we have 0. Hence, so it was simple. Ultimately, you are going to substitute and multiply, and that we are getting. Ultimately, the answer is. So that was it. Let's do the 15th one. 15th one again, it is similar only. Ultimately, we have to prove this, whether this is the thing. Same thing. We'll start with y. We'll find out first order derivative of y. We'll find out second order derivative of y. And we'll check this. First order derivative. Dy by dx. Dy dx on both sides. It is actually not so difficult. Because I have the formula e to the power x, e to the power x. The 500th of constant into e to the power 7x differentiation is e to the power 7x, but it has some weird power. That means again chain rule must be applied. 600 as it is, e to the power minus 7x, e to the power minus 7x, but differentiation of this power. Minus 7x is the power, to minus 7x need to be differentiated. I at 500 e to the power 7x, 7x, the 7. 600 e to the power minus 7x, minus 7x, minus 7. I can see that 7 can be taken common. What do you say? Minus 7 plus 7. Ultimately, I want 49. One more time, we will differentiate. I'll get again 7 common. No need to multiply. 7 5s are 3500 and all. No need to put that. Let's take common. We'll make our work easy. So it's like dy by dx is this. Oops, minus 7. No? So this sign is minus. Right? That is why I cannot substitute this as y. It's not y because in y to it's a plus sign. I want plus sign. So one more time I will differentiate. So differentiating both sides with respect to x. D by dx of 7. 500 e to the power 7x minus 600 e to the power minus 7x. So it is d2y by dx2 is equal to 7 as it is out, and 500 I'm going to differentiate this term to 500 as it is again, e to the power 7x by e to the power 7x, but weird power. Same way, addition rule. That means d2y by dx2 is equal to 7 was initially out on 500 e to the power 7x into differentiation of 7x is 7 minus 600 e to the power minus 7x into differentiation of minus 7x minus 7. Again, I can see that 7 is common from both. If it is coming out, then it will become 49. So 49 into 500 e to the power 7x minus minus plus 600 e to the power minus 7x. Now I can see that this bracket is nothing but y. So it's 49 y over. Hence, proved. Bracket was nothing but y is how we can. Questions are not so difficult questions. These are very easy questions. Let's do this. Let's keep this question for the next class.